We're going to look at thermodynamics, which is basically the study of energy transfer in terms of hot and cold and temperature and things of that nature. A few basic definitions of terms that we need to get out of the way. First, the word heat. Sometimes, when we use a word in the English language, it's not always exactly in the same sense it's used in physics, and sometimes it's close, sometimes it's not so close. Heat is a case where the way we use it in English does not correspond to the physics definition. If an object feels hot, we say it has a lot of heat, but that's not actually what it means in physics. In physics, heat is energy transfer, or maybe more specifically, a thermal energy transfer, which, remember, at a molecular level, thermal energy is how fast the molecules are moving, basically. So heat, say that I have some amount of heat, doesn't make sense in terms of the physics definition of the word. I may not use that correctly all the time, but I think you should know that. Two objects are in thermal contact if energy flows between them, or energy is free to flow between them, I should say. If energy is free to flow between them. Mostly for the most part, that means that they're touching, basically. But it can also, they don't necessarily have to be touching to be in thermal contact. Thermodynamic equilibrium means that two objects are in thermal contact, but there is no heat. There is no energy being transferred between the two of them. So, if objects are touching and they're both remaining at they both have the same amount of thermal energy, not that they have the same amount of thermal energy, they both have an unchanging amount of thermal energy. That is what I mean. Each individual object keeps the same amount of thermal energy. Then they are in thermodynamic equilibrium. And then another random note is that cold is an English word, and it has no physics definition, or chemistry, whatever, no scientific definition. Cold is not a thing. If an object is cold, it has less thermal energy. An object feels cold because there is heat being transferred from us to wherever. If air feels cold, it's because there's heat radiating out from your body into the air. If you touch an object and it feels cold, it's because heat is transferring from your body to the object. So those are a few definitions in terms that are very different from the way we use them in English. Now, thermodynamics has three laws, much like Newton's laws govern mechanics. There are three laws of thermodynamics that weren't attributed to a single person, therefore they don't get a person's name like Newton's laws. They're just the laws of thermodynamics. The three laws of thermodynamics were discovered. The first, second, and third law is what they were called. And then later, they realized that there was another law that was closely related to the others, but it was worth stating on its own, and it was really more fundamental to thermodynamics than the others. And so instead of calling it the fourth law, they called this the Zeroth Law of thermodynamics. And as far as I know, Thermodynamics is the only place where I've ever seen the word zeroth. I wasn't even sure it was a word, but I don't know. It's a thing that's used in thermodynamics. Now, the Zeroth Law states that if A is in equilibrium with B and B is in equilibrium with C, so object A is in equilibrium with B and object B is in equilibrium with C, then object A is in equilibrium with C. It states that thermodynamic equilibrium is transitive. And now that seems pretty trivial, or at least it does to me, but this law allows us to define temperature, which turns out to be pretty important in things we do in thermodynamics. It allows us to define temperature, measure it, compare it, and so that's an important part of thermodynamics. And temperature is what determines whether two objects in thermal contact will have energy flow between them. Energy flows from hot to cold. So if something is hotter, it will give off thermal energy to the colder thing. And it's actually kind of interesting that only this temperature matters. It doesn't matter how much energy an object has. It doesn't matter what its specific heat is. Whether or not energy will flow is determined solely by temperature.